All right, what's going on? I'm Professor Caudill, and we're picking up where we left off on Chapter 4, Motion 2 and 3 Dimension. So far, we've gone through a good chunk of this chapter so far. Seems to be kind of a review from Vector chapter in the previous chapter. So, kind of seeing where, oh, so this is definitely from the vector problem. Given a vector, so they're breaking this down in components. So I hat, j hat. So that is same thing as this, not this one, this one. So like if the vector is 2.1 at 15 degrees, so this, I know this one we'll use a lot. So 2 and 0.5s, 2 and 0.5. Only thing they changed was it was a negative for the y. So gotta be kind of careful with what you plug in. Okay, so yeah, we ended here last time. So projectile motion. Use one-dimensional motion in perpendicular directions. Okay, so perpendicular. What comes to mind when we hear the word perpendicular? It should be the cross product. I don't know if that's what if they will use that, but that comes to my mind. So calculate the range, time of flight, maximum height of a projectile that is launched, impacts a flat horizontal surface. Okay, so basically a lot of stuff with parabolas in projectile motion. Yeah, I think this is like this topic alone is so primal, you know. When we were before we evolved into the humans, we through we would throw, we developed a spear, and then we developed the arrow as a mobile spear. Weapons development with the Darwinian evolution, kind of fascinating. Projectile motion is not motion of object thrown or rejected into the air. So the only acceleration is the result of gravity. So we're not talking about rockets. We're not talking about planes with thrusters that accelerate it. We're just talking about something that has an initial velocity. And then everything else is just gravity. So there's numerous physics and engineering applications, meteors, fireworks. Follow a trajectory, keyword trajectory. Okay, we're neglecting air resistance. So it seems we're just on 2 dimensions right now, I would say. Okay, so so in these types of problems, the acceleration in the x axis is going to be 0, but the acceleration in y is gravity. So that's basically what they're saying. So gravity in the x direction is 0. So with the givens, you kind of break down what equations are relevant. So V naught is Vx, x is that. Okay, trying to, I don't know. I don't know if I like kind of how they're presenting all this. I'd rather it be like more um, with examples, you know? Solve for the unknowns in 2 separate motions. Okay, so at least it's easier in two, like it's two, the hardest part in 3 dimensions for me is like finding the angle, because you have to find like the XY plane angle and then the XZ plane angle. So the here we really need to do TOA, which is easier. Okay, so they have a cool infograph thing. So we have angle theta. You see theta is changing over time. A lot of V's. So um, yeah, so I wonder if they're going to cut this parabola in half, because you're dealing with a negative acceleration on the left side and a positive acceleration on the right. Okay, so yeah, I'm eager to hands-on approaches. So firework display, a shell shot into the air. V naught is 70. Theta T of the fuse. Fuses time to ignite the shell just as it reaches its highest point above the ground. Okay, so that's going to be when EV so it's gonna hit here at this point. The rate of change is 0. So that's going to be how we calculate the height. Or the height will be when that is 0. Okay, so calculate the height. Where are those equations? Let me okay. So these are our equations. So what do we know? We also know a in the x is 0, a in the y is negative 9.8. Okay. And we know how to solve. Oh, so we're trying to find this vector, this vector. So probably easiest is to start with x. So since ax is 0, the velocity t is 70 using a 4.12. Okay. All right. Now dy velocity of y is y naught, which is 0. Sorry. $70 plus 9.8 e so yeah, there's really a lot to this. Kind of getting overwhelmed. Okay, so we got if anything, we got the first part, right? X naught and Y naught. I mean, that kind of goes without saying. They start at 0. So, highest point is called the apex. It's when the velocity is 0. So, this is not exactly correct. This should be this really should be y. This really should be y of t, which is vy 0. Okay. Like, I knew what I was saying, I just, yeah. It's the derivative of the position function that needs to be 0 to find the highest point. Okay, so given these, they know. So one thing I immediately questioned was this one. Is V naught, is it 70 in both the XY direction? Looks like it's not. You have to do some trig. So saying V is this, so we have to break V down in components. So if you know theta, then you can find the y component of the velocity vector. It's V naught y. So it's sine 75. So opposite over hypotenuse. So it's gonna be 70 sine over V naught y. Okay, and it looks like that's what they did here. 70 sine. So in a way, it's like just doing a puzzle. It's really just puzzle solving. You're given information. You are given kinematic equations, and you're given a question. So this is what the book will give you. They'll give you information, they'll give you the equation, and they'll give you the question. So the question, answer of the question, answer of the question is assigning kinematic equation to all information. So you have a set of information, I1, I2, and then you have a set of equations such as, you know, x t equals x naught plus v x. You know, you have your vxt is v naught plus ax t. So you're mapping the information to an equation. So this is, maybe this is backwards. I don't know, it's not like it's not a one-to-one function. Well, no, it's not, because you could have two pieces of information going to the same equation. Okay. And then you solve. So A Q is solve for the unknown AI. Don't freak out over this notation. This is just I call this pseudo math, where it's it's like taking notes but in like a pseudo math form, where it just kind of helps you spell out some ideas. It lets you sketch rough ideas even if they're not technically correct. um, it can kind of just help communicate. um, so it's saying there's more than one way to solve for time. T is V naught over T. So yeah, you can see how, I mean, definitely need to know elementary algebra. You need to know how to move things from one side of the equation to the other. You don't necessarily need to know the quadratic formula. I mean, I haven't used it once. Um, I just do this. I just do solve. Gets to the point where it's unreasonable to do a certain amount of math. Just like the future will be like, it's unreasonable not to get a second opinion from a language model when you're doing any type of calculation. Eventually it won't be, it'll be, humans will actually be in the way trying to solve problems. Like I don't know, anything can be computed. So yeah, given equation, given information, given knowns, given knowns. So we're given knowns, given equations, given a question. So the answer of the question, I guess I could rewrite this as answer of the question, solve, um, we can write this as kinematic equation at unknowns equals in meaning the n unknowns. So if the equation, okay, so that means we have to do, if it's solution to a kinematic equation with n unknowns, n number of unknowns, then you want to solve this, plug in information, and it'll be n minus 1. Because we need um, we need something to solve for. So if we know all the variables of a kinematic equation, um, its a solution should be obvious. Then you don't need to solve anything. Okay. Doing the pseudomath also helps when you're going to code stuff as well, because it lets you kind of write down what's important as well. Okay. So I'm starting to get the itch to code, but I think it's too soon. I think it's too soon. So a rock is thrown off a cliff 100 meters high, so V naught, I'm sorry, Y naught is 100. Okay, so we're just writing down our unknowns with the velocity 15. Okay, so the origin is here. No. The origin will be here. X, Y. So we want to find equation for the horizontal motion. Okay, so that means we know A in the X direction, 0, A in the Y direction. It's negative gravity. Okay, so they want to know the motion. So X of t is 0 plus so yeah. I need to convert this v into vx. I need to find vx and vy. So I need to convert this vector, this velocity vector, into x and y. Okay. So that should be v naught x. Okay, so that should be negative v x t plus 0. So I'm plugging in 4.1 into 4.13, 4.12 into 4.13. That'll be times t plus 1/2 ax is 0. Okay. All right, velocity of the point of impact. Guess that's v naught. So v squared is 15 squared plus 2 negative gravity 100. Okay. So gradient 5. Negative 9.8. 100. 0. 15. 41i, so doesn't really make sense. All right. Tennis player wins a match at Arthur Ashe Stadium, hits a ball into the stands at 30 meters per second. Okay, so y is 10 plus y naught. Y naught is 0. Okay. Okay, so I know they're going to want us to convert this into, we have a vector, so we're going to convert it into its v not x, v not y. Okay. So we're going to do that with some trig. In other words, plug it into our calculator. So .30 and 45 degrees. So v naught y 21. Okay. So we want to find t. So we're solving. So we're sol for 2. Sol t. Sol t. Sol t. So we know the final velocity is 0. Maybe we can do equation 3. Final velocity is 0 because it's getting caught. Negative 9.8 for gravity. T is what we're solving for. Initial velocity is 20. 21. 2.14. Okay. T is, they're getting 3.1. Okay, we've done everything right up to this point. They're using equation 4.22. 4.22. Why? Because why not? Why is why not? Okay, so they're using equation. They use equation 4. I use equation 3. Okay. So we should have used equation 4. Displacement is 10. Negative 9.8 times t. Initial velocity is 21 in the y direction. Initial position 0. 3.7. Okay. So our calculator works. It's just hard part is picking which function we want. So we're basically doing the same thing as the first chapter. So maybe this is just review. I'm not really sure. Okay, so now we want to solve maybe we should do sol with f4. Solving for t using function 4 gave us 3.7 seconds. Okay, now we want to know the magnitude and direction of the ball's velocity. Magnitude. Okay, so they probably want this, probably using equation 5. So we're solving with equation 5. Magnitude. Magnitude should use Pythagoras theorem though, shouldn't it? Yes. Magnitude, we'll always use Pythagoras theorem. Okay, so they're not using equation 5, they're using Pyth. So and then the angle is we should already know how to do that. Okay. So definitely using this one, and we are definitely using so for example here 21, 21. We want magnitude as well. So step 1, we did this, then so we had 21, we had 21, so 29. So that's kind of weird. Our Pythagoras theorem is a little bit off because they're using a different number here. So how did they get this number? Oh, they did the cosine. How did they get 30? They're changing something on me. Sine 45. 30 cosine 45. Okay. By is negative gt. 3.9 seconds. we get the x coordinate. Vertical velocity is this. So they did 3.9. How do we get the 3.7 again? Equation 4. We use equation 4 for 3.7. So 21 minus this. Okay, so earlier it was more simple because the Vx is V naught cosine that. Twenty-one is that. Okay. So we had this vector and what is this, 30 at 45. V is 30. So finding the x component so everything we did in the beginning was for V naught. So V naught x 21, V naught y is 21. So the question is asking for Vx is V naught x minus gt Vy. So we know gravity ax is 0, ay is like 9.8. So that's why Vx is V naught 21 meters a second. Because when you're plugging in, so this should be edited to gx, gravity in the x direction, gravity in the y direction. Okay, so that is why this is 21, and that is why this, we had to find t. So we found t with equation 4. equals equation 4 f4 of so Vy is 21 minus 9.8 times f4 so f4 is solving, so we're solving for t, and we were given 10 negative 9.8 t 21 0. Okay, so I think the book referenced these two, didn't it? So since the ball is at height 10 meters at 2 times, once away, so when I take the once, it should be time. Okay, so that makes sense. So it's going up 10 and then down to 10. So we use the longer time. Okay, so that makes sense. So we're using the max Vy 21 minus 9.8 times the max okay, and this could be rewritten as Vy. I'm just gonna rewrite it as the most abstract form. So Vy is V not Y minus G of Y times the max F4 F4 displacement, so that's Y. So that's Y. Negative gravity. E. Initial velocity. Initial position. And Y not. Okay. So as I've outlined here, everything they're doing here to get Vy is using equation 4, plugging in these variables, and these variables are not matching the book's equation. They're matching whatever SymPy outputs. So equation 4, you can see displacement. This is just change x's to y's. So x is y. We have negative gravity, negative 9.8. We have time. Then the next variable is v naught y. And then we have y naught. Okay, so that's how they get that. So with v, y, and vx, then magnitude v is the square root it's that, and then Okay, so one thing that we didn't know is we need to know why we use this. Why do we use this to solve? So the hardest part was probably just understanding you need to use this equation. To find. So it's not getting any accelerated that. Solve for t. So the thing is just like I started with equation 3. I should have started with equation 4. That's my only thing. Is what I wish. I wish I could just instantly recognize the right equation to use. So I'm debating spending like an hour or two rewriting the LaTeX to be more specific, or if we can just get away with converting it. As you can see, it's kind of a lot of code. So, um, but yeah, we're using a lot of the stuff from vectors, and then we're using the same functions here, give or take. All right, so let's recap how we answer this question. So we're given velocity vector of 30 meters at an angle 45. We want to know the time it takes to reach this, which is 10. Okay, so we want to know the time it takes to get to here, and then we want to know the velocity, the final velocity. So how did we answer this? So we took the magnitude of the vector, which is 30, took the angle of the vector, which is 45 degrees, and our calculator does the trick for us, gives us 21x. So this is 21, this is 21. Okay. Now that's the initial. Do I want to rewrite this? Calculates the cosine of the angle. Magnitude of Vx. Magnitude of V naught Y. I don't really like this. Let me make a symbol. And I want to display equation V naught X is this, and oh, what am I doing? This should be I wanted it to be here. My bad. Okay. Okay. So V naught X is 21, V naught Y is 21. Okay, and we're about out of time. So then we took yeah, so we didn't use this until the end. So let's move this. It's down. Okay, so we found 21. Then we ended up doing negative 15.9 or whatever. We got 323. Just negative, what did they get? Negative 60 degrees. Yeah, negative 39. Negative 15.9 divided by 2. Negative 15.9. Is 37 degrees. Okay, so that matches what they got. So really, we want to take this. We want to put it step one. So this we're going to insert above here. We found T, then so all right. I think you get the point. And then this negative 15.9 gets us 26.5. So all the tools we need should be here. 1, 2, 3, 4. I guess we can move this insert. We can move this above this because really we found the angle last. So magnitude. Magnitude, so magnitude angle. This solves for time. And this solves for this breaks down your velocity vector into components. All right, so I know it's a lot. Calculator makes our life easy. We just need to know how to use it. So thanks for watching, and I'll see you next time.